Good afternoon, everyone. Today we're going to start our discussion on multiple linear regression. I think last time we had this introduction, we said that linear regression is a statistical technique, the objective of which is for us to be able to describe, okay, the, uh, the variable of interest, the dependent variable, making use of our uh, explanatory or independent variables. So we want to establish a relationship and equation that we can use in order to explain the behavior of our dependent variable. Also, we said that it's used for us to forecast the values of your dependent variable given values of your independent variable. Okay, so it's modeling our dependent variable, modeling the linear relationship between them. As the name suggests, class, linear regression to, no? So there are certain assumptions that we need to have, okay, that we need to understand to fully come up with a credible or correct model as far as linear regression is concerned. Now, the method that's used is least squares method or method of least squares. If there's only one independent variable, then we call it ordinary least squares. Now, it's called least because we're trying to get the minimum. Least is the minimum, okay? Squares is the residuals squared. Squares here pertain to the residuals. And I think last time we said that residuals is a measure of the deviation of your predicted value from your actual value. So we have the data, we have the actual value of your dependent variable. So you come up with a model, and then you're able to generate your predicted value. When you compare your actual value and your predicted value, get the difference of that, you have your residual, okay? And when we add the residuals, we're actually going to get a zero value. But because that's the nature of your regression model. However, it should not be just any line that describes a relationship between your dependent and your independent variable. That line, which we call the line of best fit or regression line or least squares regression line, it's a unique line in the sense that when you square the residuals, okay, as I said a while ago, we just don't add the residuals because you get nothing out of it, you just get zero. So we square the residual first, and then we add them. When we add these residuals, it should be the minimum, okay, which means that this is a unique line. There cannot be any other line that will give us the least squares of the residuals. Okay, so all right. May I know if this one let me share this also with you. Did I share with you this LaTeX formula, class? Kindly chat, please, if I shared with you. Not chat, are you sure? Okay, sige. So, all right, this is what I meant. I think I mentioned to you the LaTeX before. So in R, you can make use of this language, LaTeX. All right, I will just explain some of this. And if you go to, so the LaTeX mathematical expressions is best is best generated by the use of LaTeX. Okay, here I'm starting with $2 signs and then ending with $2 signs. Okay, so that if I press enter here, it will generate this terms. Okay, so we will not be studying everything here, but suffice to say that, okay, this just tells us that begin aligned and end aligned. So this is just to format our text. So you notice that when it begins here, it's aligned with the one at the end. So this just aligns our text. All right. And then the equation is really this one, y sub I. Okay, by the way, let me pause for a while and ask you if kindly chat please if you got the LaTeX the LaTeX code. Were you able to copy it, class? And do not put it in a code chunk, no? Kasi hindi natin dinalagay sa code chunk yan. Okay. So yeah, let's try to understand. Thank you so much. Let's try to understand some of this. Okay. Now, the first equation is y sub I. Take a look at this. Y sub I. Okay. And how was y sub I written? Take a look at this. Y, and then the subscript is underscore, and then I. Y underscore I. So that's how you write Y subscript I. Okay, so that's very easy. And then is equal to, take a look at this, is equal to the beta, the Greek beta. Take note of this. It's written in Greek. The Greek data is written as slash beta. Okay, so when you're writing Greek symbols, which is oftentimes used in mathematics, econometrics, this is how you do it. So if you type slash backslash alpha, then it will generate the alpha. So let me change this, alpha. So what happened to my equation here? Okay, it became alpha. Okay, so let me revert to the Control Z. All right, so this is beta underscore 0, and then you have here beta underscore 1. Okay, so this is for the subscript, and then x. Okay, so take note of this, x, and then you notice that if there are two characters that should be placed as a subscript, you put it in curly brackets here. So tingnan nyo to, no? Underscore and then bracket I1. So to write I1. Okay, so quite easy, class, no? Quite easy. Ganun din once you get to learn the fundamentals, it will be it's the learning curve in LaTeX class is not that much, no? Medyo may mga terms lang na dapat aalamin, no? Okay, beta 2, x2, beta 3, x3, and then plus, and then dot plus beta underscore n, x sub I n, plus epsilon sub I. Take note of this, epsilon and underscore I. Okay, so ito yon, class. All right, so what is this? Let's go to the equation. So the linear regression line, the linear regression model is defined by this one. Your dependent variable can be explained by your independent variables multiplied by their coefficients, slope coefficients, beta 1 x1, beta 2 x2, beta 3 x3, plus the slope, okay, plus a certain error term. Now, why are we adding an error term? Because there will be, there might be a discrepancy between your actual value and your predicted value. Remember that this is your predicted value, class. This is your fitted or predicted value. Now, if you compare it with your, if you compare the actual value with your fitted or predicted value, the discrepancy, the difference will be your residual. So we put this class in order to make it equal. Otherwise, they will not be equal. Now, if I'm going to remove this, okay, so let me copy class the code here, this one. And let me just copy up to the second to the last without the epsilon. And then I'm going to put it here. Put $, and then Control V. There. And let me just fix this. Oops. $. Enter. Okay, I need to I must have written something. I-delete ko muna class. Let me rewrite it. Bakit naka-highlight si ito. So may nasulat ako dito. Okay. Okay, were you able to generate your own this equation, class? Kindly chat, please, if you were able to generate this equation. And then let's discuss that. Class, favor when you answer, please. Please share to everybody your answer unless you're asking a personal question. Kasi pag nag-chat kayo sa akin, yung next line ko nakadirect na sa inyo, no? So I will have to again message access to everyone, no? So nagwe-waste ako ng time. So unless you're asking something which you don't want others to see, nahihiya ka na magtanong about that question, then that's okay. Pero pag nag-share lang naman kayo na answer, to everyone na lang, ha? Okay, thank you. All right, so take a look at this, class. Is this equation correct? What's y sub I? Y sub I is your actual value. Okay? That's the value that you get when you, let's say you're surveying, nag-survey tayo or we got secondary data, and this is the variable of interest, this is the value that we get. Okay? And then we run a regression line, we run a model, and then we are able to solve for the beta null, beta 1, etc. Okay, so here there are n predictors and explanatory variables and independent variables. Now, would you like to comment on this? Is this relation true? This one? Or if not, what's wrong with this? Can anybody comment, please? Okay, let me see. No error term. Okay, yes. Michael. Okay, we deliberately remove the error term. Okay, now I just want you to comment on this, excluding the error term. How do you comment on this, class? Is this a true term or a false term or wrong equation? Or when will this equation be true if this is false? If this is a false equation, why so? Class, observe clearly, class. Okay, what's this? Kindly chat, please. Paki-chat. My question is, what is y sub I? Dependent variable, okay, Mike, thank you. Dependent variable, yes. Y is the dependent variable. But in particular, ano ba yung Y na to, class? These are the class actual values to, no? Sabi ko kanina, si Y class, ito yung value ng nakuha natin as a secondary data. Kunyari, it could be GDP ng Philippines, no? So we were able to get data about GDP of the Philippines. Kunyari, from 1970 to 2023. So if that's the variable that we're studying, for example, we're looking at the factors that affect the GDP or the GNP, that's our actual value. No? Ito naman, class, ano to? This is our, if we generate the model, if we generate an output where we're given the value of the intercept, beta 1, all the slope coefficients, and then if we use this and then substitute the x1, x2, x3, x4, and multiply it with the slope coefficients, what value do we get then? Ano to, class? If we perform that, yeah, correct, Gab, thank you. Gab, thank you, you're correct. This is your predicted value, class. Predicted value na to, forecasted value. We used the model that we generated, assuming we were able to generate a model. The model gave us what's the value of beta null, beta 1, etc. So we can use those values and multiply it with the x values in order to generate what we call the predicted value. So you have a particular value of your dependent variable, then you have your predicted value. Now, comment, class. Are they equal? That's my question. Is the actual value equal to your predicted value? Is that possible, class? First question, is that possible? Is this possible, class? Is it possible for your actual value to be equal to your predicted value? Yes, Adi, thank you. Yes, pwede, class. Daphne, yes, thank you. Pwede, class. The predicted value and the actual value can be equal. So if that's the case, class, is this equation valid? Is this equation valid, class? Okay, yes, thank you. Yeah, you're correct. It's valid. However, the question is, will it always be valid? Will there be a situation where it will not be valid? Will there be instances when this equality, this equation will not be valid, class? No, sir. Mark, paki-explain yung answer mo, please.
Ay, sir, yung question niya ba is always valid po ba siya?
Di ba? Sabi ko, will there be instances na hindi valid tong equality na to?
Yes, sir, may instances po.
Yes,
Through
thank you.
the
Thank
error
you, Mark.
term.
Yes, thank you. There will be instances when the actual value is not equal to the predicted value. In fact, more often than not, no? Mas maraming instances na hindi sila equal. So, in order to correct this, pwede natin ibalik yung epsilon dito. Kasi pag dinagdag natin sa epsilon, yung residual, yung difference ng actual at saka ng predicted, then magiging equal na sila. Agree, class? Agree? Agree with that, class? In order to make this equation correct all the time, class, all the time, then dapat idagdag natin sa error terms, epsilon. Ito. Do you agree, class? Do you agree? Chat, please. Come on, class. Okay, thank you. How about the others? Yan, okay? All right, thank you. Now, what we did here to make this equation correct is we add the error term here, the residual. Okay, I'll remove the residual again, and then we come up with this one. We said that this portion on the right is the predicted value or your forecasted value. This portion on the left is your actual value. Now, this is this equation is wrong. It can only be correct in certain instances when your actual value is equal to your predicted value. But generally, this equation is wrong. So how do you correct it? Either by adding epsilon here or class, or how do we change this class so that they become equal? This time, you don't add epsilon, okay, but you change this. How will you change that class? How? Any comment from the class? How do you change this so that the equation becomes always correct, always true? I think I discussed this before. Okay. Anyone, class? Would you like to comment? Pause muna ako, class. Naintindihan niyo ba yung question ko? Do you understand my question, class? Is my question understood, class? Okay, thank you. Fair. How about the others, class? I want to hear from the others if baka hindi clear yung ano, yung okay, so sabi ni Gab, yes, correct, Gab. That's correct. How can we make this equation true all the time? But don't add residual here. Huwag tayong magpa-plus epsilon dito, plus residual. So that leaves us with just changing the left-hand side. Ano gagawin natin, class? Para this equation will always be true. Anyone? Okay, minus the epsilon on the side. Okay, but normally, parang ano din, parang ganun din yun. In-introduce natin si epsilon. we don't want to introduce epsilon. So without introducing epsilon, how do we now make this equation true? Okay, simple, class. Ano ba to? Predicted value, di ba? Okay, that's your fitted value. So we just define your y sub I not as the actual value. So lagyan natin dito ng slash and then hat. Yan, tingnan nyo, class. Now, this is now the symbol for your predicted or fitted value, di ba? Okay. All right, let me pause for a while and let me allow you to write also hat there. Okay. Ito yung hat, class, no? Hat. And then andyan yung y underscore I natin. So that will be this one. Okay, thank you, Matt, for the question. The hat, class, stands for predicted. Okay, so pag nakita nyo to, let me go to ako sa Word file. Okay. So y sub I, ba? This is the actual value. Y bar, you know, what's this, class? What's this? What's this, class? Unmute na lang, please. Ano yan? Class, ano tong y bar? Class? I'm sure you have met this. Yeah, of course, average. Pauline, please share your answer to everyone. Yeah, di ba average ang class? Okay? So average, we're just making sure that naiintindihan natin mga nomenclature, ano? And then how about this class? Y sub I. Yan, ano to? This is your predicted value. Okay, question. Bakit may sub I itong actual? Bakit yung average walang sub I? Bakit yung Y hat sub I merong I? Siguro kaya nyo na explain yan. Bakit may sub I to? Ito, may sub I din, ito wala, yung average. Adi, would you like to answer that? Mr. Exconde?
Di ako sure sir dito pero
Guess lang. Sige.
at least
Okay lang.
from kasi pag average siya compared to actual and predicted values, yung average is a combination of the two, so there wouldn't parang yun yung mismong yun na kasi yung magiging parang pinaka value niya. So I'm not sure sir. So
Okay, medyo malapit naman. Siguro ang gustong sabihin ni Abby, plus yung Y average, isang value lang yan. No? For all your actual values. Di ba, how do you get the average? You add all the actual values and then divided by the number of observations. Isang value lang yung average. Itong actual value class, kung ilan yung observations nyo, yun ang iba't ibang klaseng actual values, di ba? If you have 100 observations, then you have y sub 1, y sub 2, hanggang y sub 100. Right, class? Ganun din si predicted class. So you have different, sa y sub 1 mo class, if you have y sub 1, ito yung actual value ni y sub 1. Sub 1 here class represents kunyari, your data is presented 1, 2, 3, 4, 5, 6, kunyari GDP, no? GDP, ito yung first value, second value, okay? It's an index. The first value is 100, no? So y sub 1 is equal to 100. That's the actual value. In this case, GDP. Tapos kunyari, predict natin na ang GDP is, for this particular row of observation, ang predicted value ni GDP is 102. So, ang Y hat sub 1 mo class, sub 1, no? Sub 1 is 102. So, each actual value will correspond to a particular predicted value using the model, no? Using the model that we generated, that y is equal to beta null plus beta 1 x1 plus beta 2 x2. Kasi class, di ba, ito yung y sub I natin. May x sub 1 tayo, x sub 2, x sub 3. Okay? So itong y sub 1 natin, may corresponding na x sub 1, x sub 2, x sub 3, etc. When you multiply this with the coefficients, okay, and add the intercept, then you get your predicted value. Okay? Predicted value. Okay? All right. So as for my question, y sub I class, I pertains to, it's an index, no? Kung 100 nga yan, sabi ko dapat y1 hanggang y100 yung actual values natin. Our predicted values will also be y1 up to y100. So this is just to denote class. Makikita nyo ito sa mga statistics books, sa econometrics books. Pag nakita nyo yung symbol na hat, ibig sabihin yung predicted value yan class. Okay? So going back to our discussion here. So ito class, kasi ito predicted value. Di gawin natin predicted yung y. Yun. Yun lang yun class. Okay? So that's a very basic concept class, but I hope that's very clear to us, no? So if I want to, pwede naman natin i-increase si increase natin si hat kasi parang masyadong maliit. If you want a wider hat, then wide hat lang yan. Okay, mas wider ba? Parang hindi. Ba't hindi nag-work yung wide hat? Okay, I'm not sure why the wide hat is simply added class. Wide hat lang yan. Okay, I'm not sure why It did not work now. No? Okay, anyway, hindi naman importante yun sa atin at the moment. Yan. Okay, any questions so far, class, about our equation, about the difference between y sub I is equal to this one plus epsilon, and then y hat is equal to just this one? I hope clear yun, class. Kasi pag nakakita tayo ng ganyan equations tapos hindi natin maintindihan, then masa-stuck tayo. No? Alright, sige, let's continue. Now, when you do a linear regression model, there are certain assumptions that will make the result, the output valid. Kung na-violate yung assumptions na to, baka hindi magiging valid yung ano natin, yung model natin. Okay? Kasi when we try to generate the linear regression model, we're trying to come up with the blue model. Ano yung blue? This should be the best linear unbiased estimators. So dapat yung mga coefficients natin, blue dapat yan. Best linear unbiased estimators. And that can only happen, class, if there are certain assumptions that are followed. Okay, so let's take a look at the assumptions. Number one, linearity of the data. So this has something to do with the relationship between your x and your y. Dapat yung x at saka y natin, dapat correlated sila. No? They should be correlated. So imagine, okay, let me okay, imagine you have plinat natin, class, si ano. So plinat natin si si y tapos si x. Tapos it turns out that our function looks like this. Yan. So do you think this is a linear model, class? Do you think the relationship between your y and your x is linear? The answer, of course, is no. Thank you. Yung sumagot. Yeah, thank you, Pauline. The answer is no, class. Hindi linear yan. In fact, it's a quadratic relationship. Okay. And we don't want to be using a linear model. Okay. Kasi pag mag-linear model tayo, class, ganito mangyayari sa model natin. No? Ganito. So line kasi yon. So this will now approximately how your line of best fit. So this is called your line of best fit or your ordinary least squares line. Okay, imagine if our data is like this. Our regression model is like this. So andito yung mga actual points natin. For example, andito siya. No? And then, so if you plot the residuals here, yung mga residuals is the deviation between your actual, di ba? Ito yung y sub I natin, actual y sub I. And then this is your predicted value. Itong y na to dito, xy yan, di ba? This is your y hat sub I. Okay? So this, let's say meron tayong ano dito, value dito. Ayan, no? Please ignore the curve line. Sabihin natin, ito yung ano natin, data points. Ito yung actual data point natin. Ito yung predicted value natin. Ito yung residual. The difference between the predicted value, the fitted value, the model value, and your actual value, that's your residual E. Okay, so imagine creating a model when the relationship between y and x is such that it approximates a quadratic relation. Tapos, magli-linear model ka. Ang laki ng risk, hindi na magiging blue yan. Hindi na siya magiging best linear unbiased estimator. Kasi dapat sa best linear unbiased estimator class, dapat the method is called least squares. Sabi natin kanina, dapat yung least, yung pinakamaliit na squared residuals. Okay? So perhaps, class, in order to model something like this, dapat quadratic din dapat yan. Quadratic model din dapat ang gagamitin natin dyan and not linear model. Okay? So I hope that's clear, class, itong linearity of the data. Na-share ko na ba ito sa inyo, class, ito? Hindi pa, no? Okay. Let's see. Partial lang kasi hindi tinatanggap ni R ni Zoom yung ano yung marami. Okay. All right. So hanggang dito, no? Okay, so number 1, class, dapat X1, X2, yung mga predictors natin, dapat strong relationship, linear relationship with the dependent variable, outcome variable Y. However, class, dapat yung mga independent variables natin, hindi sila dapat correlated. Gusto natin si Y at saka si X strongly correlated, but we don't want we don't want X and X, X1 and X2 to be strongly correlated. And the reason for that is, later on expound pa natin to, but what will happen is that they will try to compete, no? In trying to explain yung dependent variable natin. Pareho lang naman actually sila. If they're highly correlated, then halos pareho lang sila, then might as well just use one of them. So we'll that's something called multicollinearity, which I'm going to discuss in a while. All right, next, yung linearity of the parameters. What does that mean? Hindi ko yata nabigay ito. Okay, nandito. What does the linearity of parameters mean, class? Okay, so let's take a look at it, class. This one. So dapat, sa assumption 1, dapat linear yung relationship ni Y at saka ni X. Yung pangalawa naman, class, linearity of the parameters. What does that mean? When the model, class, this says, should be linear in the parameters, which means dapat yung mga betas natin, yung mga coefficients natin, dapat hindi pa pwede siyang hindi linear. When we say linear, non-linear, hindi dapat siya naka-square, naka-square root, naka-reciprocal. Okay, so take a look at this. Ito equation na binigay ko sa inyo. Yan. Okay? So andito yung equation 1, okay? Andito yung next line to, di ba? Andito si y sabay, etc. Now take note, si beta 1, and how was it written? / beta underscore 1 for the beta 1, and then caret 2. Ito naman yung naka-square, caret. No? So meron ka naka-underscore. Ito yun. Meron ka naman naka-superscript. Ito, 2. So that's very easy. No? So beta 1 squared. So ang sinasabi dito, class, hindi pwedeng si beta naka-square. Hindi pwedeng si beta naka-square root. Hindi pwedeng si beta naka-log or naka-power transformation o naka-reciprocal 1 over beta. Why? Because it will be very difficult to solve that. Kung yung coefficients natin, kung yung mga parameters natin, hindi linear. Dapat linear. Pero class, tingnan nyo to. Ito, binigay ko sa inyo, di ba? Ito pwede. So what's this? Ang naka-x dito yung independent variable natin. Pwede yan. Pwede naka-square si x, pwede naka-log si x, pwede naka-1 over x, pwede yun. Okay? That can be solved. Pero, hindi yung parameters. Okay? Alright, paki-chat please kung so far okay in discussion natin. Nakakahabol ba? Clear ba yung pag-explain ko? Feedback please. Any questions? Thank you, Pauline. How about the others? Kyla, thank you. Okay, may question dito. Dali ah. So far, di pa nakakaiyak. Okay, thank you, Adi. Let me see. My question dito. So, so equation 2 is linear po ba? Okay. Equation 2 class is linear in parameters, but not in the independent variables. Kasi si x mo dito naka-square eh. Di ba? Okay? Now, I'm not saying class na yung x squared dito, I'm not saying that, let me rephrase my ano, no? Let me rephrase, yung dalawang conditions natin, yung assumption number 1, dapat linear yung relationship ni x and y. Okay? Pangalawa, linear in parameters. Ibig sabihin, when you craft the equation, hindi pa pwedeng si beta naka-square or si beta naka-square root or si beta naka-log or 1 over square root of beta. Hindi pa pwede yun. Dapat beta, si parameter sa atin, dapat linear lang. Ayan, as is. Beta 1, beta 2, beta sub n. Okay, pero pa pwede, you can establish a model, whether it's a linear model or not, class. Pwedeng ang naka-square yung x, naka-log yung x. Yun ang sinasabi ko lang dito. I'm not saying class na, I'm not saying na linear model din to. No? Okay? I'm not saying that when you generate a model to describe the relationship between y and x, linear model din to. What I'm saying is, yung assumption natin na number 2, linear in parameters, yung beta dapat hindi naka-power, hindi naka-squared. Kasi mahirap i-solve yan, class. Okay, that's the reason why dapat linear in parameters. Okay, because of the difficulty in modeling this. Now, yung x, pwedeng naka-squared. Okay, mamomodel yan. But I'm not saying that the model, if it was s squared, I'm not saying that it's a linear model, no? Okay, we have to check kung linear model ba yan. Okay, did that answer your question? Who was the one who asked, Mark? Clear ba yun? Okay, thank you. Thank you, Mark, for that question. All right, then, hindi ko pa na-share to, no? How about this class? Let's see, hanggang dito. 4 to 16 natin. Chat natin. Okay, yan, nakopy. All right, there are other assumptions. Number 1. Number 3, homogeneity of residuals variance. What does that mean, class? Homogeneity, dapat yung residuals class, ang distribution niya, dapat constant yung variance. So what do we mean by that? Balik ako sa word. Okay. So suppose, class, we plot okay, i-plot natin yung residuals natin. Okay, it can be iba yung residuals natin, let's call it E, and this E sub I, and this is the difference between your actual and your predicted value. Let's let's plot it with X. Okay, so there are many things that could happen to this. So pwedeng yung residuals natin, random siya, okay? Random siya. And let's say 3 standard deviations, hindi siya lumalabas doon. Okay? So take a look at this. Itong residuals sa to class, random siya. No? Random, tapos constant yung variance. Ibig sabihin ng class, hindi siya lumalampas dito sa lines na to. Kasi pag non-constant yung variance, pwedeng it's possible that your residuals would behave this way. Yan class, no? Non-constant variance yan. Why is it non-constant variance pag ganyan yung residuals natin? Kasi for example, over this levels of y, pwedeng pwedeng parang medyo ito lang yung average ng residual variance mo, no? Residuals. Pero pagdating dito sa level na to, hindi na eh, no? Hindi na, ito na yung mean ng residuals natin. Iba na dito. Right? So ito, may trend yung residuals, hindi constant variance yan. Ito class, yung kanina, yung what I drew, okay? Random siya, tapos walang trend. Wala ring fanning out, kasi ganito yung fanning out, no? Parang ganyan. May trend, tapos meron pang increasing yung variance. No? Iba yung variance dito, iba dito, iba dito. Okay, or it can be fanning out, pag ganyan. Pababa, no? Okay, so that's how, which means class that we will have to study the residuals. Kasi the assumptions of classical linear regression model is anchored on the residuals. Yung difference ng actual value natin at saka ng ano, ng predicted value. Okay? So when the distribution of the residuals is constant, ang tawag natin diyan homoscedastic. On the other hand, kapag other spread, kapag may trend, etc., it's what we call heteroscedastic, and we don't want that. Okay? Kasi pag heteroscedastic yung ano natin, then possibly class, hindi na blue yung ano natin, coefficients. Diba sabi natin kanina, best linear unbiased estimators. Baka bias na siya. No? Okay, so that's something we're going to discuss as we go along, as far as homogeneity of residual variance is concerned. Next, ito class, I discussed this with you. Ito. Explanatory variables are not collinear. We don't want the correlation between the explanatory variables to be high. Ayaw natin yun. We don't want the independent variables to be correlated to each other. And I mentioned this a while ago. That's what we call multicollinearity. It exists when two or more variables are highly correlated. So, mahirap siya class kasi when you're creating a linear regression model, you would want to see how much a particular variable explains the variance of your dependent variable. Eh kung highly correlated sila, parang ang hirap ma-disentangle. Ilang percent ba ang ine-explain ni variable 1? Anong proportion ng variance ng dependent variable natin ang ine-explain ni independent variable 2? So there can be difficulty as far as disentangling which of them best explains the variance of your outcome variable. Kasi nagkakaroon tayo ng shared variance ngayon kasi related sila eh. Correlated sila. Okay? So also, in terms of parsimony, bakit ka gagamit ng dalawang variables when in fact, pareho lang naman sila, no? Kung highly correlated sila, good modeling dictates that just use one of those variables to explain. For what reason? For many reasons. Number one, for practicality. Kasi kung magsa-survey ka, class, tapos dalawang variables ang kukunin mo. Kunyari, just a very crude example. Kinuha mo si age. Tapos, tinanong mo pa yung responded, so what's your age times 2? Diba? Hello? Ba't mo titingnan yung age times 2? Related naman yung sa age. Diba? Times 2 mo lang. Kaya I might be giving a very crude, no? Crude example. No? But, yan ang importante dito. No? Dapat hindi sila yung variables natin should not be multicollinear. Okay, number 5, independence of the residual terms. Now, I think last time we discussed the difference between cross-sectional data, cross-sectional, time series, and yung panel. Okay, question. Where here will be where here will most likely have uh, troub- problems as far as independence of residuals? Sa cross-sectional data ba, time series at saka panel? The answer, class, is saan, class? Ayan, okay. Saan dito, class? Dito ba? Cross-sectional ba? O time series or panel? Saan tayo magkakaproblema? Okay. Yes, thank you. Thank you. You're correct, no? Panel data, class. Bakit, class, mas magkakaproblema tayo sa panel o kaya sa time series? Kasi, class, may inherent na arrangement yung data na yan. So suppose you have data from 1970 hanggang 2023. Okay. Now, we cannot reorder this. Hindi natin pa pwede. I feel ko, gusto ko 2022 muna, tapos 2018, tapos 1978. Hindi pa pwede yun. May inherent order yung time series natin at saka panel data natin. So that, pag kinompute natin yung residuals, class, hindi natin pwedeng babaguhin yung order ng residuals. Okay? So there you can see if yung residual in 1970 related ba sa residual in 1971, etc. Kung related ba yung mga how do I put it? Yung mga consecutive na residuals na yan. Unlike sa cross-sectional data, class. Okay, pwede mo i-arrange yung data mo na observe yung data mo ng alphabetical. Pwede mo siyang i-arrange from A to Z, Z to A. Pwede mo siyang i-randomize lang. Okay? The model values will not change. Pareho pa rin. Okay? So yung consecutive na residuals, kasi tinitingnan natin dito yung independence. Ibig sabihin yung consecutive na residuals natin. Kung nagde-depend ba yung previous natin dun sa succeeding. Okay? Since the data can be rearranged, then ito, class, immaterial or irrelevant to sa isang cross-sectional data. This will only have a bearing when we go to your time series and panel data. Okay. Now, lastly, you have your normality of residuals. Ibig sabihin, when you plot the residuals, dapat medyo normally distributed siya. Okay. Now, of all the assumptions, this is the least important. No? Okay, so in fact, the normality of residuals will not have any bearing if you have a very huge data set. Okay, pag malaki yung data set natin, class, walang bearing yung normality ng residuals. Okay, however, there is one other topic here which hindi ko sinali dito. Yung another assumption ng classical linear regression model is dapat there should be no outliers. No? Outliers are data points that are extremely outside the other data sets. Kung i-compare natin siya, ang layo-layo niya. No? Ang layo-layo ng outlier. And related to outlier are what we call influential data points at saka leverage points. So we're going to discuss that also. So not only outlier but also influential data points at saka leverage points. Okay, so dali lang ha. Okay. Saan na yung clear all ko dito? Oh. Okay. Natin. All right. Okay, let me just share the references here. You may wish to look at some materials. By the way, class, the discussion here is not included in the first exams. So I think I'm deciding to put it next Monday, no? Not this Monday. Yung first face-to-face exams natin. Okay, which will cover just the module 1, yung data structures, yung list, vectors, arrays, etc. Okay, so balikan natin sandali ito, class, no? Let's go back here and then let's just discuss this very quickly. The first assumption, class, is that linearity of the data, which means that your x and y should be linearly related. No? Okay, so let's create a code chunk. If you recall code chunk, Control-Alt-I or Command-Option-I for Mac. Okay, and then we're going to generate a random numbers. Okay, mag-create tayo ng data, tapos titingnan natin yung relationship no, ng x at saka y. Tapos tingnan natin kung i-model natin sila, ano mangyayari kung ang minomodel natin is if they're not linear, tapos gagamitin natin ng linear model, what will happen? Okay? So the first thing that we need to learn is the function set.seed. Okay, susulat natin dito, class, set.seed. So ano yung set.seed, class? Set.seed is a function that's used in order to generate the same random numbers. Okay? Mag-aansan ng same random numbers. So you just supply it with a number, any number, may natin 1, 2, 3. Okay? You can name it, you can number it any way you want. So pwedeng single digit, 5 digit, etc. When we have the same set.seed, 1, 2, 3, we will generate the same random numbers. Okay, so let's create a variable. Gagamitin natin. May function sa R. Okay, let's take a look at this. Run if. All right, yan. No? Okay, yan. Run if. Okay, so this is random uniform distribution. Okay, yan, run if class. So, ang parameters niya and kung ilan observations ang gusto natin, minimum at saka maximum. Okay, so if you're familiar with uniform distribution, it looks like a rectangle. Yung distribution niya distributed equally throughout your data points. Okay? So if you plot it, parang ano siya, parang rectangle ang lalabas. No? So that's what a uniform distribution is. So mag-generate tayo ng set of numbers na pare-pareho tayo kasi nag-set.seed tayo. And kung ilan yung observations, minimum and maximum. No? Ito yung default, minimum is equal to 0, maximum is equal to 1. Which means, class, kung hindi natin isama tong 0 and 1, okay, yan ang ibibigay niya. Okay, so let's create this object. Okay, X. I'll call it capital X. All right. Then, okay, ano to, class? If you have watched the videos, class, alam nyo to. What's the name for this? Anyone? What's the name for this? We call it this one, class. Less than and then dash. Okay, Adi, it's called thank you, but complete assignment operator. No? It's called assignment operator. Okay, so you are assigning, thank you, Adi, your assignment, no, hindi assignment operator. Okay, you are assigning X to whatever this value is. So you're putting a label, you're putting a name to whatever value we get here. So sige, lagyan natin run if. Okay, and then let's generate 50 numbers. And then let's just make it minimum is equal to Ang minimum natin is equal to -5. Ang maximum natin is 5. Okay, so this will generate a set of random numbers from -5 to 5. And then if you plot it, makikita nyo na siya. Ang distribution niya parang rectangle, no? Kasi uniform eh. Uniform distribution. All right, let's run this class. Set seed 1 to 3, x run if 50 random numbers, minimum is -5, maximum is 5. Okay, let me run this. Okay, so if you take a look at your environment class, okay, so sa environment natin, under values, meron na tayong na-generate na object, no? The object is called x, and it's, what does this mean? It's numerical, it's a number. There are 50 observations from 1 to 50, and then the first observation is -2.12, 2.88, -0.91, etc. All right, questions, quick answers class, ha? Chat nyo kagad yung answer. How many observations do we have as far as x is concerned? How many? Please chat, everyone. Okay, 5 lang ba, class? How many? Okay, 50, class, no? Kasi, okay, tingnan natin, class, kung first, tingnan natin, class. Oops, sorry. Ibang ano ang count, no? Wait. Shucks, nakalimutan ko yung pag-count ng vector. Wait, ha? Anyway, hindi ko na i-code, class, no? Kasi andito naman siya, no? There are 50 observations, 1 to 50. Close ko lang to sandali, ha? And then, if we use the function head, and then x, our object x, this will give us the first 6 observations. Control Enter. Run natin yan. So what do you notice about, length, sorry, Carlo, yeah, thank you for that, no? Nakalimutan ko yung, I was thinking of another function, no? Length ng x, correct. Yan. For a vector, we can use length. Okay. Length of x is 50. So there are 50 observations. Thank you, Carlo. And then, yung head ng x, head x natin, class, it will generate, by default, it will generate the first 6 observations. Okay, and if I make it 10 observations, oops, kalimutan ko yung close, Control Enter, there, first 10 observations. Question, class, how does my values for x compare with that of yours? How does it compare? All right, bakit the same kaya, Carlos? Carlos, please share your answer to everyone. Carlos, kindly
Yes,
share
sir.
share your answer to everyone. Why do you think it's the same?
I'm not too sure, sir.
Okay, sige. Explain ko na lang, oh. The same siya, class, kasi ginamit natin yung set.seed. Okay, we use the set.seed function. Ito, class. If per chance, sige, tanggalin natin tong set.seed, ha. Tapos, semicolon, head, x. All right, I'll run this, class. Walang set.seed. I'll run this, so R will generate a new random number called X, no? 50 of which minimum is -5, maximum is 5. And then I ask R to generate the first 6 observations. Tingnan nyo class, nagbago na, no? And then if you run this, it will be different from your values. Kasi hindi tayo nag-set that seed. Control Z, balik ko na. Okay. So this is very important for us to have the same set of random numbers. Set that seed 1, 2, 3. Okay? Yes, Pauline?
Sir, yung sa akin I observed, it's different kahit nakaset that seed ako na 1, 2, 3.
Okay, sige, ulitin natin ha. Sabi ni Pauline's different daw. All right. So, okay. Balik ko to ha. Pauline, i-run mo to. Baka hin-highlight mo lang kanina to. Palagay ko, hin-highlight mo lang to. Hindi mo nasama yung set that seed. Pero if you, everything inside the code chunk, tapos i-run ko yung code chunk, okay, then again, bumalik yung kanina, -2.12.
Okay
Paki-confirm,
po, kita.
Pauline.
Nako.
So
Okay
what
na po.
was, ano yung, what made it different? Hindi mo siguro
Ah.
nasama yung set that seed, no?
Opo, yung pag-run. Yung
Okay,
X
siguro
lang.
dito mo lang siguro linagay yung cursor mo. Okay?
Okay po.
So dapat if you want to run all the codes in your code chunk, dito mo siya i-run, no? If you want to just run a particular line, dito lang. Anywhere here, no? In a particular code. Okay, so next class, let's generate. Sana makahabol tayo dun sa kabilang section. But ang gagawin ko class, i-share ko yung video ng kabilang section kasi mas nauna kami doon. No? Okay, I'm going to generate another object. By the way, class, what's the shortcut for assignment operator? Kasi ang tagal niyan pag less than at saka minus eh. What's the shortcut for this? This is called assignment operator. Sulat ko dito. Okay. What's the shortcut for that? Yeah, thank you, Carlos. It's Alt minus, no? So I think for Mac, it's Option minus. So subukan nyo nga, class, Alt minus, para hindi nyo ita-type yung ano. Mas mabilis kasi Alt minus. Kasi kung greater than pa, mag-ano ka pa, Shift, less than, and then saka minus, no? Tatlong keys. Pag Alt minus, mas mabilis. Yeah, thank you. Gab, it's Option minus. All right, so dito class, mag-generate naman tayo ng random normal distribution. So I'm going to generate an R norm. Yan. R norm, 50 din, no? I-match natin si X, 50. And then ang syntax ito, tingnan nyo class, so mean is equal to 0. So pwede natin i-write mean is equal to 0 and SD is equal to 1, which is the default class. We learned last time that if it's the default, pwede natin hindi na natin isama to. Yung mean is equal to 0. But if I want a different mean, I can change this. Kunyari, mean 10, standard deviation 2, etc. So it depends on what type of distribution you want. Pero itong R norm class, this is random numbers generating a normal distribution. Okay, R norm siya. Okay, and then i-help nyo na lang kung ano yung syntax kasi marami yung tayo matututunan dyan, kaso in the interest of time. All right? And then lastly, I'm going to create our variable y. So capital Y, Alt minus in my case, and then I'm going to make it X, okay, X caret 2 plus, let's say 3.5 times X plus a certain random number. All right. Small u dapat. Yan. Okay, take a look at y. Notice our y will be generated by multiplying whatever x you get, i-square niya, tapos i-add niya yung 3.5 times x plus yung u, no? Yung u na random numbers lang yan na normally distributed. So question, how many values of y will you be getting, class? How many values of y are you going to get? Okay, thank you, correct. Dayan, thank you. And Mark, 50. Bakit 50? Kasi 50 yung x values natin. 50 din yung values ng u natin, di ba? 50-50 yan. So si y natin, of course, 50. All right? So I'll just run everything again. So x dito, wala pa akong u. If I run everything, yung code chunk na to, there, I will now have u, x, and y here. No? So meron na tayong u, meron tayong x, meron tayong y. And then, dapat pare-pareho tayo class ng values, ha? Kasi kung pare-pareho tayong x, kung pare-pareho tayong u, therefore pare-pareho tayong y. No? Okay? We will have the same. I-plot naman natin class sa ilalim. We're taking a look kasi at the linearity relationship. Again, alt minus. Sorry. Ay, mali. Control alt I pala. I was thinking of code chunk. So let's just plot. I-plot ko lang class si ano. I have a few more minutes. Plot si x muna, comma, y. Okay, tingnan natin how the plot will look like. All right. So tingnan nyo class yung ano, yung relationship ni x and y. Do they look like they're linear, yung relationship? Class? Okay. So, mukhang hindi linear yung relationship nila, di ba, class? Di ba? Alright. So, ang gagawin natin dito, class, pag mag-regression tayo dito, as I showed you a while ago, that might not be the best, ano. Okay, so, if we do a regression model here, ito, kunyari ito yung regression line natin. Sorry for the ano, kung hindi ano ha. Yung in-explain ko kanina, no? This might not be the best model. Kasi hindi linear yung relationship ni x and y. Diba, class? In fact, tingnan natin, class, ha? Ay, may naulit ba? Okay. Plot lang, plot. Okay. I-x ko na muna to. Clear all drawings, tapos x. So if we get, class, the correlation ng ni x at saka ni y, okay, it's 0.84. Mataas naman, class, yung correlation. Unfortunately, yung correlation yan, yung shape niya, hindi naman siya mukhang linear, no? It looks more quadratic than linear. Okay, so, okay, I'll just have, medyo nauna na kasi yung ano, no, yung kabilang section. May few code chunks kaming ginawa na mukhang mahirap kung introduce ko pa ngayon. So, tell you what, class, I'm going to post also the video of the first section, and kindly watch na lang yung latest parts na lang nila, ng mga 5 minutes na lang or 10 minutes. Kasi may in-explain ako doon na we don't have time to explain it here kasi it will take me long, no? So, kindly do that, please. Ipopost ko rin yung video ng kabilang section. Then, i-add nyo na lang 5 minutes dun sa dulo ng recording na yan. Okay? Okay, may question dito for the quiz on Monday. Not this Monday pa, next Monday na, no? Yes, it will not include this one, hindi pa, no? Yung ano lang, yung introduction to R and R Studio, yung module niyon. All right, I hope you learned something today, class. So let me stop recording now.